So, good morning, everybody. First of all, I want to thank the ESUG board for having me here, and the organizer, of course, also. Today, I'm presenting what I'm doing for music with Pharo. I don't. How many of you were at ESUG last year? Quite a few. Yeah, so just a few words about me. I'm Domenico Cipriani, also known as Lucrezio. I'm mainly a DJ and music producer and a linguist. I have an MA in linguistics. And in my spare time, I also like to say that I am a small talk activist because I like everybody. I'm talking everybody about small talk and Pharo. And so this thing of music with Pharo is to give the people a tool to make music with Pharo. Okay, so actually we are not generating the music in Pharo for now. Hopefully we can do the music inside Pharo. We will see how later. But now we think Pharo as an OSC, Open Sound Control, MIDI, performer, sequencer, and controller. So we can have all this free stuff. It was intended for live coding music. That is an increasingly popular practice of doing music and show the screen with the code to the people. I don't know if any of you has ever heard about algo raves. So there was, like, in the last 10 years, this algo rave stuff was very popular. It was made popular, I would say, by especially by Alex McLean and Tidal Cycle. That is a language, a domain-specific language for Haskell. Okay, that is the most popular language for that. But I was using that, but I was also thinking that this is very, for a beginner, is very hard to use Tidal Cycle. And I think Pharo was the first. Smalltalk was the first programming language that I learned because I started to use Kima. Kima is a programming language made by Symbolic Sound, and it used Smalltalk. So I didn't know even what it was, an array, and I was learning Smalltalk. And then it was very hard to learn Smalltalk with the Kima user manual because there was very few reference. So I started to learn Pharo with the mock, how you say it, and with the book. Pharo by example, and all the book. I read all the book. I think that maybe I learned something. And then I was also helped a lot in the last 2 years by the Pharo people in Lille at Iria. So also because of them, it's possible to do this music with Pharo. So basically, Pharo can act as a client for a MIDI instrument, so we can use it for a synthesizer or for a digital audio workstation, or for an OSA audio server that of your preference can be Super Collider, Pure Data, Chuck, MSP, Mac MSP, Kima, whatever. Inside the, let's say, the big picture of music with Pharo, we have the live coding packages. Thank you. That is what I'm developing. That is using the OSC implementation that is made by Stefan. Maintained by the original idea about Marcus Gelli for Pharo, somebody. Yes, so I use the OSC implementation. And also there is Pharo Sound that was re-implemented, started by a student of Hermod, Antoine Delaby, with the help of Santiago Bragagnolo. And it's important what I've done with Pharo Sound because we have the MIDI connection implementation in Pharo Sound. And it's very good because a lot of people, when I began to develop this idea, I was just Googling and everybody was like, you cannot send MIDI from Pharo or from Smalltalk or for Squeak because it's very slow. And no, you can, and you can have very tight real-time performance. So first of all, Pharo Sound, MIDI is musical instrument digital interface, is a protocol, very old, very slow, but is used everywhere, especially in hardware synthesizer. And so there was this, Pharo Sound used this Port MIDI C, that is a cross-platform library. by the use of UFFI, you can use it inside Pharo, and you can have all the MIDI functionalities in Pharo, everything MIDI out, MIDI in, and actually it transforms Pharo into a MIDI sequencer. Also, an interesting thing is that you can create your custom GUI MIDI controllers with Pharo using that MIDI implementation. Then you have the open sound control that is at the basis of what I'm doing, because I'm using, we'll see later what we have new, but open sound control is a newer protocol of communication between instruments. It was developed in 95, 96, so it's not so new, but is newer than MIDI, is faster than MIDI, and more reliable, is lightweight, low latency, and is very widespread. And you also can not only communicate with music software, but you can also do visual, like you can connect Pharo with the live coding package to like processing or P5.js or whatever you use for your visual. And then we have the live coding package. That is what I'm doing, and is not only is a way to play sounds from an audio server or a MIDI instrument. You can create custom OSC controllers also, and it's not also like a domain specific, I call it dialect, because it is a little regional variant, and to create, transform, and manipulate melodies. So all with in mind that this is something I do it, is still very messy, but is working, is always working. There is few documentation, but I'm going to do it. And it's something that I did especially for beginners and for the young people and for people that doesn't know about live coding, because I think it's very easy to see and to understand. First of all, we have a performance. Now we will see then in action with this very small speaker, but on Wednesday we will have a bigger sound system. So the performance class is a singleton, and it is like what you can call like a tracker in the, or a digital audio workstation in the classical way of doing music. So it's a container for many sequencers, and many sequencers are like the tracks of the digital audio workstation. So the performance control of the sequencer can have all different lengths, and inside the sequencer you have different parameters that are the gates, so the notes that are actually played, the notes, so the note number, the duration of these notes, and then you have this dirt message that it's used to play the sound on Super Dirt, that is an audio engine for Super Collider, and we see this is the news of this year. Okay, so when you create a performance that is a new unique instance, is a singleton, because I just want to have a performance running in my playground, and I can decide the frequency, so speed for my performance, and I assign, the first thing I have to do is to assign a performer to my performance, because I can have a performer local that is local server, like for whatever audio server we are on the local computer, performer for MIDI hardware, a performer for Kima that is just like open sound control, but to an external machine, because Kima is running with his own hardware, with his own Ethernet. And then you have performers Super Dirt, that is actually a subclass of performer local, because it is sending message to a local server, but with a particular syntax and in a particular way to be understood by the Super Dirt audio engine. Maybe we will see a little bit of sound. Okay, so the thing is that what I liked from the last year I was performing with Kima, that is super cool, but is proprietary software. It's very expensive and is closed source, so it has a little bit of problem. Now we are using Super Dirt, that is for Super Collider. Okay, is a Quark for Super Collider, an extension for Super Collider that was created by initially by Alex McLean for being used with Tidal Cycle. There is Raphael that came here that is making something like before what I'm doing for Pharo. He did it for Python. So there are more people that doesn't like to use Haskell to do live coding. They want to use their own language of choice. So basically you just allow Super Collider that is free and open source and is very widespread. You start the Super Dirt audio server, and then you have everything you need because SuperDirt comes with a lot of sample. You can put your own sample. It comes with sound, and we will listen to some sound. So, okay, but I can create like with this syntax, like BD3, SD2, BD3. This is like you decide which sample with the name of the folder of the sample, the index in the folder, and then these tilde are like the breaks or the rests. And if you send it a message to the string for dirt, it converts this in a OSC message that is understood by SuperDirt and is playing. You assign it to a key in the performance that is rhythm. The performance is just a dictionary for the sequence. So if I assign that, and I send a message play, just for 16 bar. Can you hear something? Yeah. Or I can decide for another sound and select this note with dirt notes. So this is this. And we can also play like charts. So the syntax for SuperDirt is like you create a sequencer. Now we see what is a sequencer, how you create it. You assign a sound, you can assign charts or notes, and then you assign to a key in the performance. And that's all. So you just need Pharo and Super Collider, SuperDirt, and you can do your music. You have all the sample you need, and all the instrument you need. You have like 47 charts. You have a lot of rhythm from the world, and so I think it's really good. Okay. So how it works? We create the sequencer. We basically, sequencer are just with the, there is a thing called time unit box system that is a way to display rhythms, just like with boxes that can be black or white or full or with an X, and basically it can be converted like, we can think that about like an array of 1 and 0, where 1 is a trigger and 0 is a rest. So this is the live coding dialect on the most right. Then you have the traditional notation for the real musician. And then you have this time unit box system that is like what it is in between the traditional and the live coding dialect, okay? So performance is like a multi-track with this sequencer. You have assigned a performer to the performance because I think we are doing double dispatch. Maybe I understood. Maybe I understood. So you just send play to the performance, and the performance play, and the performance is a process with very high priority, actually like 80 of priority. So it's like it's sucking all the resources to Pharo when it's running. And yes, that's all. You can assign how many tracks you want, then you can mute them, you can solo them, and this is a different stuff. This is like for MIDI connection. So you can use Pharo with a live coding package for SuperDirt via OSC, or you can connect your MIDI synthesizer and use the port MIDI port inside Pharo. And so you don't need to download Super Collider, you don't need to download SuperDirt, but you can connect it to your synthesizer. If you have Moog or Electron or whatever you have, a keyboard at home, you can play it. And it works the same. The only thing is that you have to assign a MIDI channel, and MIDI channel are just 16. So, because MIDI is like that. How you create a sequencer with the live coding dialect? So there were 3 principles in mind creating stuff. This live coding package, maybe something is a little bit violating the essence of Smalltalk, but I like it like that. So the first thing is iconicity. So in a way, the code should resemble what we hear. And that I think is very good, again, for beginner and young people learning to code, to live code music, because 16 upbeats are like 16 steps of upbeats. So you decide, you can send a message with a particular rhythm to an integer, and you just create the sequencer, okay? In number of steps, in 16th at the moment. Then there was another principle of economy. the less we type, the better, because we are performing and we don't want to just have 5 minutes to write something. So you have this kind of ugly thing where you can add, if you send a message plus to array, you have a transposition, okay? And then you have polysemy, so there are many ways to do the same thing, and you can decide what you prefer and what is better for you at the moment. So you can say, ask for 8 down bits, that is kind of fast to type. Then you can write the array by yourself and converting as sec, that is a little bit more to type. And then you can send a message x bit to 8, that converts that into an array again with this thing called x bit that I should have here something. So x bit is basically taking the x symbols, converting to nibble of 1 and 0, and creating a rhythm. This is also like a practice very widespread in live coding, because you can express very complex rhythm with very few symbols. And then also you have chart and scale and arpeggios. Last year we have just scale. This year we have also charts. We have like 47 type of charts. So for those that doesn't know music, also you can experiment with chart and just listen to the sound of chart you like. There is this syntax is a little bit resembling what we have in tidal cycles. So you have the string, you put your charts, and the root number, the root node is separated by the name of the chart from with a minus. Okay, it's kind of, it's like that. And the same thing, you can arpeggiate this chart. So you can say the message arpeggiate, and it creates an arpeggio. I have it here. Okay, so you can also do arpeggios with this syntax. Then we have a stochastic method to create random thing, because live coder and electronic musician really likes random things. So you can ask for random trigs, and it's just random gates. You can ask for random trigs with a probability from 0 to 100. You can ask for random samples from a folder. So it's basically you, on the string, you have the name of the folder inside the superdirt folder. And it parses and it knows how big is the folder. And so it gives you a random sample for that. Maybe we can listen to that. We are cascading message because you send all the messages to, yeah. Random tom. Okay. So you're sending the first message to the sequencer, that is 64 semi-quavers, and then you're sending 2, that is putting that to the performance, and now. What I'm missing here? This is the 2 that is missing. Yeah. And I have to play it. There are a lot of samples in the CPU folder. I'm happy about that. Okay, so you can ask for random node from a scale, and you can ask for random samples, assigning that to a rhythm. Then you have also methods, transformative methods. So you have like things to transform the sequencer. So with a comma, just with a comma, you join sequencer. That is very fast. You can offset the sequencer by a number of steps to the left or to the right with negative numbers. You can reverse sequencer. You can flip sequencer. That means that rests becomes gates and gates become rest. We can listen maybe here. I don't know the time. Yeah. La la la. So. We just see this. So these are arpeggio. We stop it. We check what we have in the next minutes. Oh, la la. Okay, so we were just talking about SuperDIR before. It's what is new this year. So it's cool that you just need Pharo and Super Collider, and you can do your music, and that's all. You don't have to pay anybody. The syntax for SuperDIR, we said before, is just a lot of strings with SuperDIR because it is in the like a little bit going to what is already in tidal cycles. That is, like, sometimes they call it like a string-oriented language because everything is a string. But I think also this is something that, for what I've seen, the people that are using tidal cycles, they like it, this live coding package with Pharo, because it's easier to install. You have, what I didn't say before is that Pharo is super cool to do live coding because it's already a text editor, and you just download your package and boom, it goes. With other language, you have to download an editor, you have to download the extension, then you have to download a compiler for the language, you have to hope that everything is working, and it's a lot of work, especially for musicians that are very lazy. But if you give it something that resembles that syntax in a way, they are happy to use it. You can also play sound once. This is a little bit the dirt message that is just a very, very big OSC messages where the address is /dirt/play, and then you have a lot of things that you're adding this array, and then for every step of the sequencer, the sequencer is checking if you have a gate, is sending the message. If you don't have the gate, it's just going away. With a delay, I'm using delay to go from a step to another of Pharo. I must say that the delay of Pharo is very good because I say that there is like, sometimes there is like a jittering around 15 microseconds, something like that. That is cool for performance. What about the future? More and more tests that I already have tested. Last year I had 0 tests. Now I have like 50, 60 tests. That is something. Better documentation and tutorials. It would be cool to have a custom playground with its own variable. More GUI elements that we didn't see now. Maybe later, maybe Wednesday. Generate sound inside Pharo itself, embedding the Faust compiler. I hope we can do something like that. Maybe in the web browser with Pharo.js, because a lot of people, they don't like to download anything. They just want to use it from the browser. It's okay. It's like that. Thank you. Any question? Good. Merci. This is Fabrizio, my cat, that was helping me with the live coding pen.